Right. Hi students, this video is for exercise 5.3 where you have implicit function. What is implicit function? It's a function where you have both x and y variables and you are supposed to differentiate only one variable with respect to the other variable. The function where one is the dependent and the other is independent and we cannot extract one of the variable from the functions, then it is called an implicit function. See, if you see carefully, we cannot extract x value or y value from these. And I'll tell you, when you are doing with respect to x, you are asked to do all the problems with respect to x. When you find some other variable y, then we have to write dy by dx. That's what I'll tell you. See carefully here in the first question, the function is given like this. The equation is given like, and you are asked to find dy by dx for all the problems. How to find dy by dx for this? Now what I do is differentiating with respect to x. And when you are asked to dy by dx here, x is a variable and y is also a variable and y is not a constant. Except y and x, the other things are all constants. Okay. So when y is not a constant, what to do? I'll tell you. So differentiating with respect to x, 2 into derivative of x is 1. 3 into derivative of y is not 1. It is dy by dx because we are doing with respect to x. Is equal to derivative of sin x, it is cos x. So let us extract dy by dx from here. 3 dy by dx is cos x minus 2. So dy by dx is cos x minus 2 by 3. In the same way, suppose that means whenever you find y, we differentiate that and we write dy by dx. We should not forget that. Okay, now suppose 2x plus 3y is equal to sin y. If it is like this, differentiate with respect to x. With respect to x, so 2 into 1, 3 into derivative of y is not 1. It is dy by dx. Whenever we find y. Now sin y. How to write sin y? So we don't know the derivative of sin y, but we know the derivative of sin x. So we treat that y as x, like how we did in the last exercise. So derivative of sin x is cos x. So it becomes cos x. X is y here. Into dy by chain rule into dy by dx of the thing which we assume as x. What did we assume as x? Y. So be careful with that. So no need to write this bracket also. You can just write dy by dx. Now we need dy by dx. No? So take all the dy by dx terms to one side. So when I take dy by dx right side common, it becomes cos y minus 3. So dy by dx will be is equal to 2 by cos y minus 3. That's it. Right? See in the third question, what did they give? Ax plus by square is equal to cos y. Now let us differentiate. Same case. Whenever we have find y, we assume it as x and we take the chain rule. But don't treat it as a constant because we are supposed to take dy by dx. Now differentiating both sides with respect to x. Now a is a constant, 1 into derivative of x is 1. B is a constant, y is not a constant, y is a variable, y square. But we know the derivative of x square. Assume y as x. X square. Derivative of x square is 2x. Here x is equal to 2x. See x square 2x into the thing which we assumed as x. What did we assume as x? We assumed y as x, no? dy by dx. Whenever you find y, you have to write into dy by dx. Cos y minus sin y dy by dx. Whenever you find the derivative of something like y in terms of y, you should write dy by dx. Bring all the y terms to one side. If I take dy by dx common here, it becomes 2by plus sin y is equal to minus a. So dy by dx becomes minus a by 2by plus sin y. In the same way, see the fourth problem. You are given xy plus y square is equal to tan x plus y. Now let us do directly differentiating with respect to x. With respect to x. Now here x and y both are not constants and both are variables only. Now when both are variables, we take uv rule. uv, okay, x dy by dx because this is a variable plus y into derivative of x 1 derivative of x is 1 plus c y square derivative. I told you whenever you find y, 2y dy by dx is equal to derivative of tan x is secant square x, no problem, and derivative of y is not 1, it is dy by dx. I'll tell you. See, whenever you find derivative of x square, it is 2x, but derivative of y square, 2y dy by dx. Derivative of sin x is cos x. d by dx of sin x is cos x. d by dx of sin y, cos y dy by dx. Okay. d by dx of x cube, 3x square. d by dx of y cube, 3y square dy by dx. Like that. You just remember that. Now let us bring all the dy by dx terms towards left side. It becomes x plus 2y minus 1. And bring all the other terms to the right side. It becomes secant square x minus y. So dy by dx becomes secant square x minus y by x plus 2y minus 1. Now see the fifth problem. They gave x square plus xy plus y square is equal to 100. Now let us see. Differentiating both sides, this is 2x and here it becomes uv root, uv derivative of v plus v derivative of u 1, and I told you y square derivative 2y dy by dx is 0. Now take dy by dx common, left side it becomes x plus 2y is equal to minus of 2x plus 5 when you take the other terms to the right side. So it becomes dy by dx is minus of 2x plus y by x plus 2y. Okay. Now see the sixth question. Same like this, x cube plus x square y plus xy square plus y cube is 81. Same. You will have to do uv rule here and also here. Let us do differentiating. It becomes 3x square uv. Okay. X square into derivative of y dy by dx plus y into derivative of x square 2x plus here also uv x into derivative of y square 2y dy by dx plus y square into derivative of x is 1 plus y cube derivative 3y square dy by dx is equal to 0. Let us keep all the dy by dx terms to the left side. So it becomes dy by dx. So it becomes x square plus 2xy plus 3y square is equal to, now take all the other terms to the right side, minus of 3x square plus 2xy plus y square. So it becomes dy by dx is equal to minus of 3x square plus 2xy plus y square by x square plus 2xy plus 3y square. Okay. Okay, see the seventh problem. Sin square y plus cos xy is equal to k. So let us do differentiating. We need dy by dx. I told you differentiating on both sides. Whenever you have a square, we should treat it as a whole square. Okay. Now it becomes d by dx of sin y whole square. Let us write little carefully. And this becomes d by dx of cos xy. No doubt this is constant 0. Now here be careful. We treat this as x square. It becomes 2x. 2 into sin y into d by dx of sin y. Plus, derivative of cos is, treat this as x minus sin of xy into d by dx of xy is equal to 0. Now, 2 sin y, derivative of sin y becomes cos y dy by dx minus sin of xy. Now it becomes uv rule here. X dy by dx y into 1 is equal to 0. Now 2 sin y cos y becomes sin 2y. Sin 2y dy by dx minus, let us split this, it becomes x sin xy dy by dx minus y sin xy is equal to 0. Keep the dy by dx terms to the left side. so that you will have sine 2y minus x into sine xy dy by dx is equal to y into sine xy. So dy by dx becomes y into sine xy by sine 2y minus x into sine xy. The thing. See the 8th question. dy by dx we need sine square x plus cos square y is 1. Differentiating. I told you when there is square, we should treat it as differentiating both sides with respect to x. Take this as d by dx of sin x whole square, d by dx of cos y whole square is 0. No, because the derivative of 1 is 0. Now, x square, treat it as x square, it becomes 2x. 2 into sin x into d by chain rule, d by dx of sin x plus it becomes 2 into cos y into d by dx of cos y is equal to 0. Now, it becomes 2 sin x, derivative of sin x is cos x, it becomes 2 cos y, derivative of cos y is minus sin y into dy by dx, don't forget to write dy by dx. So we need dy by dx, but before that it becomes sin 2x and it becomes minus sin 2y dy by dx. So let us keep dy by dx term to the left side. It becomes minus, no 2, only sin 2y. Minus sin 2y dy by dx is equal to minus sin 2x. So dy by dx becomes sin 2x by sin 2y. Okay. See, from 9th problem onward, these are the problems of inverse trigonometry functions. We substitute something so that the whole thing becomes a formula. See, 2x by 1 plus x square, it looks like a formula when you substitute x as tan theta. And theta becomes tan inverse x. What happens? Y equal to sine inverse of 2 tan theta by 1 plus tan square theta. This is nothing but the formula of sine 2 theta. So you will have 2 theta and 2 theta is nothing but 2 tan inverse x and it becomes 2 into 1 by 1 plus x square. The same thing happens in all the problems and the derivative, dy by dx will be derivative of tan inverse x is 1 by 1 plus x square. Suppose in the 10th problem also, if I take y is equal to tan inverse of 3x minus x cube and the things that they have given beside that are the conditions for the function to exist. Here if I take x as tan theta and theta is tan inverse x, the same thing happens, tan inverse of it become 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So it becomes tan inverse of tan 3 theta and it becomes 3 theta and become 3, what is theta? Tan inverse x. Now if you differentiate this, you will get 3 by 1 plus x square. Now see the 11th question. Same ditto. Y is equal to cos inverse 1 minus x square by 1 plus x. It looks like a cos 2 theta. When you substitute x as tan theta and theta is tan inverse x, the same thing for all. Cos inverse of 1 minus tan square theta by 1 plus tan square theta is nothing but the formula of cos 2 theta. Cos 2 theta, it becomes 2 theta, y is 2 tan inverse x. When you take differentiation, dy by dx, it becomes 2 into 1 by 1 plus x square. See the 12th also. What if sin inverse is there outside and cos inverse, cos theta formula comes inside? I'll tell you, this is the formula. See the same thing we do, same thing, x equal to tan theta, 12th one, and theta is tan inverse x and y becomes sin inverse of 1 minus tan square theta by 1 plus tan square theta, and it becomes y equal to sin inverse of cos 2 theta. We can't cancel this. Then what? Then we take this as sin 90 minus theta. Then we can cancel sin inverse and sin. It becomes pi by 2 minus 2 theta, where theta becomes tan inverse x. So dy by dx becomes 0 minus 2 into 1 by 1 plus x square. Okay. Same happens in the case of cos outside and inside sin. See, cos inverse 13th formula. It becomes cos inverse of 2x by 1 plus x square. See, when you substitute, take tan theta here, y equal to cos inverse of, it becomes sin 2 theta. Same we do, cos inverse of cos 90 minus theta, and it becomes y equal to pi by 2 minus 2 theta. Pi by 2 minus what is theta? Tan inverse x. So dy by dx becomes 0 minus 2 into 1 by 1 plus x square, like that. See the 14th problem. See, this is not of substituting tan. It is little different. So we have to substitute x as sin theta or cos theta, so that the inside value becomes, see what happens, 2 sin theta, and it becomes cos theta, because 1 minus sin square is cos square and a root cos square is cos theta. Yes. Now it becomes sin inverse of sin 2 theta. So it becomes 2 theta. It becomes 2 sin inverse x. You can also take x as cos theta. Okay. And the intervals given there are the domains. Yes, those will hold. So it becomes 2 into derivative of dy by dx 1 by root of 1 minus x square. In the same way, 15th question, if I see, it is secant inverse. Something should be there in terms of secant inside. It looks like when I take x as cos theta and theta is cos inverse x, the problem becomes secant inverse of 1 by 2 cos square theta minus 1. So it becomes secant inverse of 1 by cos 2 theta. Now you can write it as secant inverse of secant 2 theta. So it becomes sec 2 theta. What is theta? Cos inverse x. Now if we take the differentiation here, dy by dx minus 2 by root of 1 minus x square. Cos inverse x derivative is minus 1 by root of 1 minus x square. Alright? All the best, guys.